So first I'm going to take the doubts from the exercise, because we have finished with the topic how to find the derivative by first principle method. To find derivative by first principle method. I have finished the questions from the miscellaneous exercise also. So first let me know if you have any doubt in any of the question, whether it is from the miscellaneous exercise or something else. Only 3 students has come out of 11. So let me see. Any doubt, beta, in this? Please let me know. Yes, Noorpreet, Rana Kanwar, that Garima has left the meeting. My voice is audible to you people?
Yes, sir.
Okay, कोई डाउट बेटा आप लोगों को इसमें?
No, sir.
Great. तो चलिए, what is today's topic? How to find derivative? How to find derivative with the help of formula? Okay. अब देखिए, what is the first result? The first result is derivative of variable to the power constant. Here x is a variable, n is a constant. Derivative of variable to the power constant. This is always is equal to constant comes at front. This is variable n minus 1. For example, if I will write derivative of x5, so this is equal to constant comes at front, x5 minus 1, which is equal to 5x4. This is the derivative of x raised to power 5. We did the derivative of x square also by using first principle. With the help of formula, how we will, now 2 is a constant, 2 comes at front, this is the variable, then n minus 1, that means 2 minus 1. So this is 2x raised to power 1, which can be written as 2x. Now, third example I am going to give you. Suppose derivative of 10x. Now, 10 is a constant, so 10 comes at front. Derivative of x. So what do you mean by x? X has which power? X has a power 1. So when I will find out the derivative, 1 comes at front, x 1 minus 1. Because what is my formula? Derivative of x raised to power n. This is n comes at front, x n minus 1. So which is equal to 10x raised to power 0. That is 10 is to 1, which is equal to 10. So if there is a constant, suppose derivative of, I am saying only 10. Now see, there is no variable, so derivative of constant will be 0. So these all are the example of my first rule. If you have variable raised to power constant, so that means derivative of variable, please note it down on your notebooks, raised to power constant. This is equal to constant at comes at front, then variable constant minus 1. You have to reduce the power of the power of the variable by 1. This is multiplication. So this is the formula. I hope this is clear. Any doubt to any student in this? Any doubt to any student?
No, sir.
Great. कोई और बच्चे को डाउट हो बेटा?
No, sir.
चलिए, then we will move to the next. Okay. Now you have to remember few results. मैंने पहले भी आपको लिख के दिए थे कुछ results जो थे. Now if there is a product of two functions, when product of two functions are given, beta, what do you mean by product of two functions? Suppose let one function be u and second be v. एक फंक्शन को हमने u ले लिया और दूसरे को v ले लिया. क्लियर? So I want to get the derivative of u is to v. That means there are two functions, उसका product. तो उसके लिए rule क्या है? First function as it is, you will find the derivative of the second function plus second function as it is, you will find the derivative of first function. This is called product rule. That means first function as it is, multiply by derivative of second function plus second function as it is to derivative of first function. इसको नोट करिए, then we will go with the questions based on this. Any doubt in understanding this question?
No, sir.
Actually, no. Everyone has noted. Can I clear it?
Yes, sir.
For example, suppose he's saying phi is equal to x square sine x. Now see, there are two functions. This is the product of two functions. One is an algebraic function. Second is a trigonometric function. Fine. So this function is u and this function is v. So this is the product of two functions. So what is derivative with respect to x? My first function as it is, then I will take the derivative of the second function. Then my second function as it is, then I will take the derivative of first function. So my u is x square, derivative of v, this is sine x. My v is as it is, which is sine x. Derivative of u, my u is x square. So which is x square as it is, derivative of sine x, cos x. You have to remember that derivative of sine x, this is equal to cos x, plus sine x as it is, derivative of x square, this is 2x. Why? Because in the previous topic we have discussed variable raised for constant. Constant come at front, x, this is 2 minus 1. So 2x raised per 1, which is 2x. So I have written 2x. So what is my answer? My answer is x square cos x plus 2x sine x. This is my final answer. Kanwar, I feel it is clear to you.
Yes, sir.
Great. Ayush, what happened? You have joined late.
The meeting ID meeting.
बेटा मीटिंग आईडी तो व्हाट्सएप पे भी इसीलिए भेजी थी कि देर आज कुछ प्रॉब्लम चल रही है, तो इसलिए व्हाट्सएप वाली भेजी कि वहां से ज्वाइन कर लो.
यस सर, मैंने गलती से दूसरी वाली पे क्लिक कर दिया
अच्छा
था जो
चलिए कोई. So my dy by dx, this is x square cos x plus 2x sin x. This is the final answer. Fine. This is the first example. Still, I will take the examples from NCERT also. For example, if y is equal to x plus 1 is to 3x square plus 2x. Now see, again, this is a product of two functions. This is my first function. This is my second function. Although both are the algebraic function, no issue. Product of function होना चाहिए, चाहे वो दोनों algebraic हैं या फिर दोनों constant हैं. It will not matter. Who product of two functions. So whenever there is a product of two functions, you have to apply product rule in solving the question. Now see, when you will solve this question, what will happen? Derivative dy by dx. So my first function as it is, derivative of second function. My second function as it is, derivative of first function. Now, this is as it is, derivative of 3x square first. So this is equal to 3 constant as it is. Power comes at front is to 2x over 2 minus 1, that is 1, so I will not write, plus derivative of 2x, 2 as it is, derivative of x, it is 1. We have already done, plus 3x square plus 2x as it is, derivative of x, it is 1. Derivative of 1 constant hai, so derivative of constant is 0. So this is x plus 1 is to 3 is to 2, 6, x plus 2 plus 3x square plus 2x multiply by 1, so it will be as it is. So you can multiply also 6x square plus 2x plus 6x plus 2 plus 3x square plus 2x. So this is 9x square plus 4, 6 plus 2, 8 plus 2, 10. This is 10x plus 2. This is my derivative. So any doubt in this question to any student? Then I'm going to start with the NCERT.
No, sir, no doubt.
No doubt. Now, come to, now we will try to finish the examples which we have done with the first principle. We will try to solve it with the formula also. So, आप note कर लें. As soon as you will note down, let me know. Then I will move to the example 12 of NCERT. Let me know as soon as you will note down. Then move to the next one. Can I go further?
Yes, sir.
Kanwar, have you noted? Garima?
Yes, sir.
Beta bata
Yes,
do.
sir.
Bata.
Yes, sir.
Okay. Now, example 12 of NCERT. So it is fx is equal to 1 over x. So we did with the help of the first principle method. Now, f dash x we will do with the help of formula. So first, I will not write f dash x, first fx. First, I have to make suitable to apply the product rule. X go in the numerator, so it will be x raised to power minus 1. Now my f dash x. Now constant comes at front. This is variable. Power will be reduced by 1. So which is minus 1 x raised to power minus 2, which is minus 1 upon x square. This is the derivative of this. So with the help of first principle, it is lengthy. But if in the paper it is mentioned that you have to solve with the first principle, तो फिर तो करना पड़ेगा. Because the terms will be subjective. So now example 13. So let y is equal to 6x raised to power 100 minus x raised to power 55 plus x. Now I have to find out the derivative. So that means derivative of y with respect to x. Because here is x variable. So this is a constant 6. It will be at front x raised to power 100. 100 comes at front x as it is 100 minus 1 because the power will be reduced by 1 minus x raised to power 55. 55 comes at front x 55 minus 1 plus x raised to power 1. So 1 comes at front x 1 minus 1. So this is 6 multiplied by 100. This is 600. X raised to power 99 minus 55 x raised to power 54 plus 1 multiplied x raised to power 1 minus 1 0. So anything raised to power 0, it is 1. This is my dy by dx. Any doubt to any student? You're free to ask. Ayush, is it clear? Are you getting Ayush? I think he is not in the class.
Yes, sir.
Okay. Fine. My next example, example 14. So you have to get the derivative of fx is equal to 1 plus x plus x square, then x cube, x raised to power 50 at x is equal to 1. This is very important. Now you have to find out the derivative at x is equal to 1. What do you mean by this? First, you will get the derivative, then substitute the value of x as a 1 to get the answer. It has 2 steps. In the first step, we will find the derivative of this question. After finding the derivative, we will substitute the value of x in this to get our answer. So f dash x. Now, derivative of constant, it is 0. Derivative of variable, it is 1. Derivative of 2x square, this is 2 is to x. Derivative of x cube, this is 3 is to x square, because 3 comes first, then power will be reduced by 1 up to 50 x raised to power 49. This is the derivative. Now, at x is equal to 1. F dash 1, this is equal to, wherever there is x, I will substitute 1. So this is 0, I will not write. This is 1 plus 2 is to 1 plus 3 is to 1 square up to so on. 50 is to 1 raised to power 49. So which is 1 plus 2 plus 3 plus 4 up to 50. So sum of first 50 terms. हमने फॉर्मूला किया था AP में, n is to n plus 1 over 2. This is sum of n terms. So this is 50 plus 1 upon 2. So which is 51 upon 2. This is 25. So which implies f dash 1. This is 25 is to 51. After multiplication, this is your final answer. Any doubt in this? So we have 2 periods today. One student has left, Ayush has left. Everyone has noted?
Yes, sir.
Yes, sir.
Okay, so join through next link बेटा, दूसरे लिंक से ज्वाइन करो, ठीक है, क्योंकि ये शेड्यूल आधे घंटे के लिए थी, तो उससे ज्वाइन कर लो. I will again rejoin. Fine. Thank you.